So welcome to the lab video for week number 3, and today the goal for this particular video is to ask ourselves that how can we convert the existing linked list which only stores integers for string. How can we convert this same class for storing string instead of integer data type, right? So pause this video and think for a while before you can go and proceed with watching the video, that how can you come up with a solution to this problem. What are the places in this code where we need to replace int with string, right? And then come again and watch it from there. So it's going to give you an opportunity to think on your own, that in case if you are presented with a problem, how can you solve that problem without taking help from anyone else? Because I've noticed that the best of the programmers never jump to the solution. They always think on their own, and then they compare their own solution with the one proposed by other people. So in this case, I'm going to go ahead and say, well, where do we store information? And of course, we store it in the structure, which is called a link node. And we are storing two things, the data in the node and the pointer which points to the next node. So what we can do here is we can come here and say, instead of storing the integer, we can store strings. And similarly, in the constructor of the linked list, we can come here and replace this string data with that. We don't have to change the pointer. We don't have to touch it because the pointer is a pointer, it's storing an address. And the only thing that you need to think about is that wherever we want the client to pass a value that we want to insert into the node, into the list, that particular file has to be changed. That particular data has to be changed. So let's start from the beginning of the class. And here we have a constructor, and it initializes the size and to 0, because the size is the variable which keeps the current size of the linked list. And the second is the pointer, which we initialize to null. Then down here, add front is where the things begin. I mean, we are inserting a new value, and observe the data type of the value variable, and it is of type int, and we want to store strings. So we're going to say string. And I think we don't have to touch anything in the implementation of this particular member function. Let's talk about the print. And print, all it does is printing all the values, and we don't have to change anything here. So let's go and talk about the add member function, which, if you remember, adds a value to the end of the list. And again, the argument is of type integer, so we have to convert this to the string, because the goal of this demo is to convert the same class for storing string data rather than integers. And I think we don't have to change anything else. Let's talk about contains. And contains take an integer value and search that value into the list. But because our underlying structure is now storing strings, so we have to convert this to the string, right? If I were to code this in Java, the equal operator doesn't work with strings in Java. We have a special method called equals, but in C++, that's fine. So we're going to leave it there. And now get front is important. Can you guess that what should be the return type of this function? Yes, absolutely right. Because we are storing strings, so if we call the get front member function on the linked list object, it's going to return the string value, because our linked list is now storing strings rather than integers. And for the remove front, we don't have to do anything because we already have inserted values of type string. So nothing to change here. And then let's talk about the get value. And get value returns the value at a given index. Can you tell me that whether or not we should change this particular index variable or parameter of the function to type string? Yes, absolutely no, because it represents an index of the array, and it will always be a positive integer, starting from 0, 1, 2, 3, 4, 5, up to the size -1. So we don't have to change anything here. It has to be int, because an index will always be an integer. And I think that's it for this particular class. And let's try storing strings in this particular linked list. So the first thing to do is to create a linked list object. Let's call this a list, and then we say list.add, and we are going to store Ali because we are storing strings now. List.add, let's store Asif. List.add, let's store Saeed, and one more list.add, and let's store Ahmed. Right? So one thing to remember is that we have no limitation on how many elements can we insert into the linked list, and that was the difference between a vector, between an array implementation and the linked list implementation. Another thing to keep in mind that it doesn't require that copy operation we used to have in the vector implementation, because if the initial size of the array in vector class was 10 and you want to insert 11th element, there has to be a copy operation. We had to create a new array of double the size of the original, copy all the elements from the old array, and then delete the old array and update the pointer to point to the new array. But it doesn't happen in the linked list, so it's a very good data structure for insertion and deletion. And in particular, if you want to insert something in the beginning, or you want to remove something in the beginning or in the middle. So now let's run the program and test the output is correct. So now let's compile this particular code to see if we've made any errors. And as you can see, the green line, there's always a happy line. That means there are no syntactical errors in our program. So if we run this program, nothing would happen because we haven't printed the list. So let me call the list.print member function we implemented, and then now let's run the program. And here is our output, and we can see that we have printed our list because the add member function add item to the end of the list. So Ali was first added, then at the end Asif, then at the end Saeed, and finally Ahmed was appended to the list. Now let's give it a try and remove the front element, and the front element is Ali. So if we remove front, our list will be Asif, Saeed, and Ahmed, and there will be no Ali in the list anymore. So let me just, after the print function, let me just call this list.remove front and then print the list again, just to see if the value from the front, which is Ali, have been removed or not. So let's run the program again. And as you can see, Ali is no longer in the list. Now let me try the contains member function, which searches an element in the list. At this very moment, Ali is no longer in the list because we have removed it from the front. So I'm going to say cout bool lpalm. As you remember from the previous lecture, it converts the 0 to false and 1 to true. And I'm going to say list.contains, and I'm going to search Ali. It should return false because Ali has already been removed at this point in the program. So let's run the program and see the output. And as you can see, it returns false. But if you want to search Asif, which does exist in the list, so I'm going to just come here and say Asif. Control S to save changes, compile and run the program, and it should return true. And here is the result. So thanks for watching. See you next time.